Hello everyone, in this video we'll be attempting to solve the assessment problem 10.1 from the book Electric Circuits by James W.Nilsson and Susan A. Riedel. In this question, it states that for each of the following sets of voltages and current, calculate the real and reactive power in the line between networks A and B in the circuit shown. This is the circuit that we have to consider. In each case, state whether the power flows from A to B or vice versa. Also state whether magnetizing wires are being transferred from A to B or vice versa. So firstly, we have to calculate the real power. We are given 4 different questions using options, and we have to calculate the real power and the reactive power of each of these options. So firstly we have to calculate the real power, and then we have to calculate the reactive power, and then we have to figure out whether the power flow is from A to B or vice versa. And also we have to figure out how whether the magnetic wires are transferred from A to B or B to A. So, and that we can figure out using reactive power. So let's attempt one of these questions, and if we are clear with one of these questions, then we can easily solve the rest. So let's attempt the answer for A. So we have the formula for real power is P is equal to Vm Im by 2 cos theta V minus theta I. So theta V is basically the phase angle of the voltage, and this is our voltage equation, and it's written in the form V is equal to Vm cos omega t plus theta. So over here our theta is minus 45 and our Vm is 100. Our Im, it's written, the current equation is I is equal to 20 cos omega t plus 15, and it's written in the form I is equal to Im cos omega t plus theta, and our phase angle for the current is 15 degrees. So Im is this part 20, so we'll multiply into 20 divided by 2, and we have cos theta V minus theta I. So what is theta V? So firstly, this is in the form of cos omega t plus theta, right? So we don't have a plus here, we have a minus, so our phase angle is minus 45 degrees, and then we have minus theta I is 15. Now if we plug these values in our calculator, we'll get an answer of 500 watts, and the unit for real power is in watt. Okay, so we are done with the real power. Let's calculate the reactive power, and which is represented by Q. So it's the same formula. We have Vm Im. Let's write it directly, 100 into 20 divided by 2. The only difference is we have to write sine instead. So sine minus 45 minus 15, which is minus 60. So after calculating, we'll get an answer of minus 866.03 var. So this is the unit for reactive power is in vars. So let's find the direction, whether it's from A to B or B to A. So this is the real power. So we can see, since it's positive, we're assuming that the current is flowing from A to B. So if we get a positive answer, that means it's flowing from A to B. If we get a minus sign, that means it's flowing from B to A. Since we got the real power as positive, that means power is flowing from A to B. And the reactive power, since the answer is in negative, that means it's flowing from B to A. This is from B to A, this is from A to B. Likewise, if we see the answer for B using the same method of solving the question, we'll find out that the power is minus 866.03 watts and the reactive power is 500 watts. Sorry, 500 watts. So this means that the power is flowing from B to A in this case, and the magnetizing bars are flowing from A to B since it's positive. Similarly, we can solve the questions C and D and quite easily. So this is it for the video. Thanks for listening and see you in the next video.